Other dating methods, this is chapter 38. One other evidence is the influx of materials into the ocean that give evidence for a young Earth. If I was to draw this hydrologic cycle, would this be the land? And cycle, of course, is that the water evaporates from the ocean, forms clouds. Clouds, by the wind, move over the earth, and then you have rain, and then the waters run into the ocean. Solomon said, the rivers run into the oceans and they are not full. But the point that I want to make today is that when this rain hits the earth and runs the ocean, it carries with it two things. It carries with it sediments, for example, soil. Mississippi River, you look at it, it's got soil mixed up, churned up. It's not just clear blue drinking water. Also, as it runs over the soil, it dissolves chemicals, any salts and so forth. The water that comes up from the ocean is pure. In other words, when it evaporates, the salt and the sediment stays in the ocean. It gets pure water that is evaporated, and then it forms clouds, and still even rainwater is quite pure. It's got some dissolved chemicals from the atmosphere. But then when it washes over the land, then you're going to have these dissolved chemicals. It is estimated that there are 27.5 billion tons of sediment being transported into the ocean every year. If the Earth was 4.5 billion years old, and if 27.5 billion tons of sediment was added to the ocean every year, the oceans would have been full. So the fact that the oceans are not filled with sediment indicates that the Earth is much younger than evolutionists say. The same thing goes for dissolved chemicals. They have analyzed various chemicals in the ocean and have analyzed the increase in concentrations. For example, the salt, common salt, sodium chloride, the chlorine concentrations, the sodium concentrations. If they assumed that it was uniform rate, which is, of course, an assumption, again, it would show a much younger Earth than the 5 billion years that evolutionists say. Now, also, usually when they do calculations like that, they assume that the ocean had no salt in the beginning, but God could have created a saltwater ocean in the beginning, too, and that would also give a younger Earth. The river deltas is another thing. As that sediment comes down into the ocean, this, for example, is down here, the Gulf of Mexico near New Orleans. The Mississippi River, the delta, or the land that it creates by that sediment, increases like about 1/16 of a mile every year. And it was 1 mile every 16 years. Now, if the Earth is 6,000 years old, as we say it is, that would have meant that the delta has increased about 375 miles. That's reasonable. But if we've been here billions of years, well, the whole landmass would be solid. The delta would have been far longer. So river deltas is another indication. Now, again, I want to emphasize, this emphasizes uniform rates of erosions, which we haven't observed. But what I'm saying, these are the same techniques that they use on radioactivity and so forth to try to show an old Earth using the same principles. We could show a young Earth by using some other example. Now, here's one that's probably a better example of all in showing the young Earth. Helium concentration in the Earth's atmosphere. Most helium was probably produced by radioactivity in the Earth's crust. One of the products of radiation is alpha particles. Alpha particles are helium nucleus. As radioactivity occurs in the Earth's crust, it gives off helium and emits it into the atmosphere. If this rate of helium flow from the Earth was constant, and if the Earth was billions of years old, as they say, there should be more than 1 million times more of the helium concentration than that which exists today. And because of gravity, very little helium escapes into space. So the fact that there's so little helium in the Earth's atmosphere is another indication of a young Earth. We talked about the Apollo mission in their attempts to determine the origin of the moon. They know that space dust produced by the breakup of comets, meteors, meteorites, and so forth, this regularly settles on the surface of the Earth and the moon. Now, on the Earth, a lot of that burns up in the atmosphere, but the moon has no atmosphere. So the moon gets an accumulation of space dust regularly. They knew that this space dust would be hitting the moon, and evolutionists thought the Earth being 4.5 billion years old, and the moon being about the same age, they thought that the space dust would be several hundred feet deep. That's why they built these lunar landing modules, because they didn't want this landing craft to hit the moon and then sink into oblivion. So there was a lot of extra weight and strength built into Apollo 11 to prevent that from sinking into what they thought was going to be hundreds of feet of dust on the moon. Well, what happened when they got there? Instead of there being hundreds of feet of dust, you could actually, can you see the footprints there? Just a couple inches or so on the moon. And this would again indicate a young moon. Now, one of the things that was very interesting is that America put the first man on the moon and wanted to get the proper public relations. Just like a mountain climber, when he climbs the top of the mountain, he likes to put the flag of his country. Well, the U.S. government, when they got the moon, they wanted to put the U.S. flag. What they had planned to do was just stick the flagpole in the dust. How many have ever been skiing? You go and you take a rest for a while, and you take your skis and you just stick them into the snow. That's a neat way to store your skis while you go into the lodge and have a cup of hot chocolate or whatever, sandwich or something like that. You just stick it in. Well, they thought, well, let's just stick the flag in the dust. Well, it wouldn't go in. It was only a couple inches. And of course, they wanted to nationally televise this, so they had to gerrymander a little device that would make it stand rather than just plug, depending on the dust. I think it's interesting to read a little bit about this. This is Buzz Aldrin, what he's saying. During a pause in experiments, Neil, this is referring to Neil Armstrong, suggested we proceed with the flag. It took both of us to set it up, and it was nearly a disaster. Public relations obviously needs practice, just as everything else does. A small telescoping arm was attached to the flagpole to keep the flag extended and perpendicular. As hard as we tried, the telescope wouldn't fully extend. Thus, the flag, which should have been flat, had its own permanent, unique wave. Then, to our dismay, the staff of the pole wouldn't go far enough into the lunar surface to support itself in an upright position. After much struggling, we finally coaxed it to remain upright, but in a most precarious position. I dreaded the possibility of the American flag collapsing into the lunar dust in front of the television camera. So they were glad that they were finally able to do it, but what I was trying to make is there was not the dust that they expected, because they expected the moon to be very old. They expected hundreds of feet of dust, and it wasn't.